Okay, so now we're going to look at uh, another form of Green's theorem, which gives us information about circulation or flow around a curve, and the higher dimensional version of that, which is called Stokes' theorem. So we're going to start, I'm just going to define this vector quantity called the curl. And so we've had this del operator we've been working with in the context of either the gradient or divergence. Divergence was when we did del dotted with a vector field. And so now we're going to define a quantity where we imagine taking this del operator and crossing it, finding the cross product with our vector field. And similar to when we tried to do this with divergence, this is not a real vector. I'm in my mind, or in my visually, I'm putting vector in quotes here because it's not operating on anything. See, this is blank here. So this doesn't mean anything. This just means an operator. The idea of applying a partial derivative to something. But we're going to use this shorthand notation of thinking of it as if it was a vector so that we can define this quantity. This is just a shorthand way to help us remember this quantity. And what we mean by taking the cross product in quotes of this operator vector with PQR is normally when you take the cross product, let's look at our I component. We would normally take the product of these two terms minus the product of these two. But instead of the product, now we're going to apply this operator to this function minus applying this operator to this function. So that's going to look like this. And then we can continue the same idea for finding the J and K components. So let's just fill those in briefly. Okay, and then we end up with this three-dimensional vector. And so now I'm just going to tell you, I'm actually going to use some videos that I really love from Khan Academy, done by the guy who now has 3 Blue 1 Brown YouTube. But I'm going to piece together just pieces of these, and I'm going to show you where I'm getting them from. So you could always just go directly there and watch them. But I know it's a lot, and so I'm just going to piece together the key ones that I enjoy. But the goal is I'd like to give you some intuition about what this vector represents in terms of the vector field. We're not going to prove it yet. These videos are just going to show you physically, and you have no reason to believe us until we prove it. We're going to prove it on the next couple pages of this handout. But for now, before we do, I just want you to picture and have a visual as to what this vector represents.